All right, my friends, let's look at a couple of examples. Example 1, part A, graph the quantity x minus 3 squared minus 4/9 times the quantity y plus 2 squared equals -1. Okay, so again, anytime you want to pause the video, work ahead of me, totally fine with me. So I'll just pretend you've done that. At this time, this would not be considered in standard form. The main reason for that is because you don't have a +1 here. So step 1, get things in standard form, and a main piece of that is always going to be to get exactly +1 on the right side of the equal sign. So let's divide both sides by -1. I'm going to go ahead and distribute that division in on the left side. I'm also going to go ahead and write this term first since it's now positive. The 4/9 here is really kind of, I'd say, inconvenient. So to get this piece of the equation in standard form, I would, instead of flip and multiply, I'd flip and divide. So multiplying by 4/9 is the same as dividing by 9/4. Okay, so just a couple notes. 1, of course, is the same as 1 squared, and 9/4 is the same as the quantity 3/2 squared. Okay, so graphing this thing, let's see, where is it shifted to? It's shifted to the right 3 and down 2. So here's its center. Let's see, for the boundary box, let's go vertically from the center up and down 1.5 units. And then horizontally to the right and to the left 1 unit. Drawing your boundary box. Okay. Which way will this hyperbola open? Since your y term ended up being positive when you got it into standard form, it would open in the y direction. Keep in mind your hyperbola will always be tangent to your boundary box. And make sure that your hyperbola demonstrates asymptotic behavior. There we go. We've got it nice and graphed. Part B, let's say I ask you to find the coordinates of the foci. And label them on your graph. Okay. To do this, you could get started with the Pythagorean identity for hyperbolas, which is c squared equals a squared plus b squared. You're finding the c value in this case. A and b, so a would be 3/2 and b would be 1. So a squared would be, say, 9/4 and b would be 1. Square root both sides, don't forget plus or minus. There we go. Okay. Keep in mind what C is. This is a common place where people forget that simple little concept. C is always the distance from your center to your foci. So if I was to approximate this, let's see, what's square root 13? Is that little between 3 and 4? Let's say it's like 3.6. Divided by 2, you have about 1.8. So we're going to go from your center up about 1.8 units, and from your center down about 1.8 units to your foci, okay? All right, so remember your foci are always on your transverse axis. That would be this guy right here, okay? Okay, so what would the coordinates be? Well, what are the coordinates of the center right there? Its x coordinate is 3, and I claim that we just went up and down, so the x coordinates of your foci should also be 3. Well, what was your y coordinate? It was -2. My spacing is not good here. And then you're going to go up root 13 over 2 to get to this one. You're going to go down root 13 over 2 to get to the other one. There we go. All right, my friends. So those are the coordinates of the foci. Okay, let's look at example 2. Let's see, what could we do to make these a little more challenging for you? I know. We could make it so it's not already in standard form. Okay, so let's talk about diagnosing this. When you get to the test and everything's all mixed up, it's going to be really nice to be able to just look at the equation and say, this is definitely going to be a hyperbola. So how could you know before doing anything to this equation? You could look at the highest powered terms. Notice you have an x squared and you have a y squared term. So that means it's not going to be a parabola or just a line graph. You could look at the coefficients. One is positive, the other one's negative. That would rule out the ellipses and the circles. So you're left with a hyperbola. So it's kind of nice to know how to diagnose these going in. All right, with that said, we're going to need to complete the square, once for the x's and once for the y's. This constant term of -14, you're going to see me kick it over to the other side. So we're going to have x squared minus 4x grouped together. The y terms, I'm going to factor that -9 out. So I'd have -9 times y squared plus 2y. And then I'm going to kick the 14 over to the other side. Okay, magic ingredient time. In the first set of parentheses, divide your linear coefficient by 2, square the result, you get 4. And I actually did just add 4, so I'm going to add 4 to the other side of the equation to balance that out. Magic ingredient in your y terms here would be 1. Looks like you just added 1. You actually just subtracted 9. See the -9 times 1? So I'm going to subtract 9 off of the other side. Okay. So now we've got x minus 2 squared minus 9 times y plus 1 squared. And on the right side, we have 9. Okay. Next thing, now that you have the squares completed, excuse me, would be to do what it takes to get the loneliest number over here. So divide both sides by 9. I'm going to distribute the division in on the left side. You'd end up with x minus 2 squared over 9, which is 3 squared, minus y plus 1 squared over 1 equals 1. Okay. Just a couple notes just to make sure we keep things straight. The 9 is 3 squared, the 1 is 1 squared. Okay, so let's go ahead and graph this. Okay, where is it centered? Got shifted to the right 2 and down 1. Let's draw the boundary box. For the x values, we're going to go to the right 3 and the left 3. And then from your center, up 1 and down 1. Okay, asymptotes. Remember, asymptotes need to go from corner to corner and also through the center. There we go. Let's figure out the orientation. Looking at your standard form, your x term is positive, so your graph should open in the x direction. Remember that your hyperbola should be tangent to the boundary box, and then it should approach the asymptotes. There we go. Okay, part B. Label the coordinates of the foci on your graph. Okay, first let's find the foci. We've got c squared would equal 3 squared or 9 plus 1 squared or 1. There we go. So c is plus or minus square root 10. Looking at your picture, remember that your foci are always located on your transverse axis, so that would be somewhere along here. Okay. Also remember what c means. C is the distance from your center out to your focus. So here's your center at 2, -1. So if you go to the right, square root 10, this one would be at 2, and then this would be at -1 plus square root 10. And then this one, oops, I should have put a point in here somewhere. It's not that, it's that. And then in here somewhere, you'd have 2. Oh, no. None of what I just said. Okay. All right. It was a 2, but you went to the right square root 10. And it's at the same y value as the center. There we go. All right, this one, the center was at 2. You're going to move to the left square root 10 to get to the focus, but the focus is the same, has the same y value as the center. Wow. There we go. Okay. All right, my friends. Part C, last thing, something that people make harder than it's supposed to be. Find the equations of the asymptotes. Okay, and this would be a really good time for you to pause it and see how you would go about something like that. Let's see if you were going to make that harder than it was supposed to be, or if you can keep it simple. Okay, and then let's talk about finding the equations of the asymptotes. Something that even our best math students forget at this stage, because you have so much going on in your math problems, is that these asymptotes are just line graphs. And if they're just line graphs, then that means that you've known how to find the equations of things like that since Algebra 1. So there's no need to do anything super fancy. So let's keep this as simple as possible. So for example, this asymptote right here that goes up as it goes to the right. Well, what's its slope? Let's just count it out. How far up and how far over do you need to go to get from the center to this point right here? Well, when we graphed your boundary box, you went up 1 and you went to the right 3. So I can't claim that the slope of this line is 1/3. I also claim that this line has to go through the center. Yeah, it has to go through these points also, but it has to go through the center. And what are the coordinates of the center? Well, the coordinates are 2, -1. So if you use point slope, you're going to have the equation of that asymptote real quick. What's it going to be? Y minus -1 or +1 equals your slope, which is 1/3, and then times x minus the x coordinate of that point you know your line has to go through. Okay, well that's the asymptote that goes up and to the right. How about the asymptote that goes down and to the right? Well, what's its slope? So its slope of this line right here, you went down 1 and to the right 3 to get there. So the slope of this line would be -1/3. And it also has to go through the point 2, -1. So its equation would be y plus 1 equals -1/3 times x minus 2. And if you look at these two equations of the two asymptotes, you'll notice that they are exact twins, except one has a positive slope of 1/3 and one has a negative slope of 1/3. So if you want, you could write this as one answer. Or one statement, I should say, representing both answers. There you go. All right, keep it simple. Point slope, count your slope out, rise over run. Both of your asymptotes go through the center, and it really should be that easy. I hope this helps everybody. Take care.